Hey, let's talk about a few theorems. Theorem 1. Let D be a subset of R, and f and g are two functions from D to R which are continuous at the point x equal to a. Then the following thing happened. The function f plus or minus g is also continuous at the same point. B. The products of these two functions also continuous at the same point. C. The quotient is also continuous at x equal to a, provided that g of a is non-zero. So the theorem is quite basic. The next one is more advanced. Consider the function f that maps the set A to R and g map the set B to R, with A and B being two subsets of R, so that fa is a subset of B. Now, if f is continuous at point x equal to a, which is an element of A, and g is continuous as another point B equal to fa, which is an element B, then the function g composed with f is continuous at point x equal to a. Okay. So here's the picture, a picture that explains the situation. First, we have a set A, and secondly, we have a set B, and the function f maps the set A into the set B. So that means the range of A is a subset of B, and then the function g map into the set R over here. And what we know is that A is this is lead away, and it would map into some B is equal to fa. Okay. And now G map the set B into R, that's what we know. And then I would denote the element C would be G composed with F at the point A. So remember, this one is just the same as this one. Yeah, that means the composition of G and F. Okay. So the composition G composed with F, we map the set A over here to R. Okay, and now we want to prove that this one is continuous at the point A here. So we assume that here what we know is this one is continuous at the point A, right? X equal to A or just A, and this one is continuous at the point B over here, just FA. And so suppose continuous here, the function f is continuous at this point, the function g is continuous at this point, then the composition also continuous at this point here, right? Okay, that's the statement, and let's see how we prove it. Okay. To prove it, then we use the definition. Now the proof. Given epsilon bigger than 0, we want to find some delta as positive, so that the composition function let me use the other notation of composition, mean G composed with F by X minus G composed with F, that's the point A, would be less than epsilon, provided that X minus A less than delta. That's what we need to prove, right? Okay, so go back to the picture above, and C minus epsilon and C plus epsilon, and we want to show that this for epsilon is given, right? So given epsilon bigger than 0, we want to show that there is some delta over here, so some delta, so that A minus delta, A plus delta could map into, let me choose a different color for this one here, and we want to see that this map, the composition here, the composition map here, would map it into a subset of the interval here, right? Okay, so the image of this interval is a subset of the interval, big interval here, right? Okay, so that's what we're trying to prove. To do that, we use the continuity of the function f and the function g, right? Okay, so indeed since g is continuous at the point B equal to FA, there exists a number delta 1 positive, said that, okay, so given epsilon here, and we say that there's delta 1 bigger than 0, such that G composed with F X minus G let me erase the composition. Just gy minus g of b and gb less than delta 1, provided that y minus b, sorry, this one is less than epsilon, okay, provided that y minus b less than delta 1. Okay, this is the definition of continuity of the function g, right, at the point b equal to fa. So g of y minus g of b less than epsilon, provided y minus b less than delta 1. Okay. Good. So now, since f is continuous at the point x equal to a, there exists a number delta 2 is a positive, such that fx minus fb fa less than delta 1, provided that x minus a less than delta 2. Okay, so in this case, actually this delta 1 plays the role of epsilon, right? And delta 2 plays the role of delta in the definition of continuity. Okay. So now, choosing delta equal to delta 2, then from this inequality, which I denote by 1 star and this one by 2 star, then from 1 star and 2 star we would get g of composed with fx minus g composed with fa let me add a sentence here for x minus a less than delta. Then what we have is this, the difference here, we can rewrite it at in this form. So this one and this one just the same thing, different way to write down. Okay, and this one here, this one y equal to fx, and this one is b, and what we know, what did we know? We know that y minus b is just fx minus fa, right? Less than delta 1. Okay, so that means y minus b absolute values, so we just know that y minus b less than absolute value less than delta 1. And then from the first inequality here, we know that as long as y minus b less than delta 1, then g of y minus gb less than epsilon. Okay, so this is by 1 star, just give us it less than epsilon, and this is because of 2 star, right? Because of 2 star, we know that y minus b less than delta 1. And now using this inequality, which is the which satisfy this condition here, then we obtain 1 star. That means gy minus gb less than epsilon. And this finish the proof. Okay, so the proof can be understood geometrically in this way. So suppose that this is the point A, this is the point B, this is the point C, and between C we just take C minus epsilon and C plus epsilon. And because the function g is continuous, we can find a guy delta 1. Okay, so here's epsilon is given. Okay, and we say that we can find delta 1 as positive, so that b minus delta 1, b plus delta 1, the whole interval here, this whole interval here would map inside the interval c minus epsilon, c plus epsilon. Okay, and now this is for the function g. Yeah. And now for the continuity of the function f, we say that I can find delta 2, some delta 2, so that this is a minus delta 2 plus delta 2, such that this interval would map inside this interval here. Okay, so then the composition now the composition G composed with F would map this rest interval into this yellow interval inside this interval, and that's finish the proof, right?